Good morning, guys.
Morning.
Right.
And welcome. Christian, you logged in on two places?
No, I don't know what happened. I had to back out of it, and then
Okay,
yeah,
that's
sorry
okay.
about that.
Oh, no problem. Okay, guys. So, good morning and welcome. And today we're going to start with what we call ultrasound physics, or yes, okay, trying to understand ultrasound physics. Okay, now just a little update, and that is that the passing score for this module here is not 70%. Okay, so I know that you guys may have been used to that. So from today and on, all the modules that you will be taking have a passing rate or percentage of 75%. Okay, okay. Now, as far as calculating those scores, etc., are concerned, it's the same. Now, for this model here, we got 4 quizzes. So 2 quizzes before the midterm, 2 quizzes after the midterm. Okay. So the average of those quizzes, yes, okay, will contribute 10% towards your aggregate score. Okay. So if at the end of, okay, yes, all your 4 quizzes, yes, okay, let's say you get 80, 80, 80, 80 in all of them. Okay. Your average is 80%. And 10% of that will be, yes, okay, contributing 8% towards your aggregate. Okay. Your midterm is 35%. The final is still 50%. And guys, that's okay. 5% is still with me. Okay. And okay, as far okay as those 5% are concerned, the main things that I just value and which is going to be it's okay based on which you will get your percentage is that you are present. If you're not going to be able to present in the class, inform me in a timely manner. Is that clear? That's point number 1. Second is, if a question is being asked, it doesn't hurt to answer wrong. Okay, because only if you answer wrong that you can get corrected. Okay. Okay. But please don't go into yes, okay, and a face-to-face where it's okay. Nobody's saying anything. If you don't understand the question, you are more than welcome to ask me, say, Mike, we didn't get your question. Okay, I can always try to, it's okay, rephrase it. Or it's okay, me, it's okay, just say it again. Okay. There's nothing wrong in saying, well, okay, at this point here, we don't know. Okay. So, any questions so far? Okay. Now, during yes, okay, towards what we can call yes, okay, the end of the course. Towards the end of the course, yes, okay, we may have a couple of days where you guys will have to, yes, okay, meet up at school. And where we, yes, okay, try to, yes, okay, we're doing a little bit of what we call, yes, okay, hands-on. Okay, and get more is okay, practically is okay, aware about how the different functions and knobs, etc., of the system works. Okay, and guys, it's not only going to be a matter of okay how they work, but it's okay also when will you use different functions. Okay, is that clear? Okay, so when to use it, when not to use it, or Okay. So, but yes, okay, those dates and so on, so on, so will be announced later. But that's going to be somewhere that's okay in 2024, if we get that far. Okay, guys. Now everybody got their books. Okay. Now, the other day somebody was very eager to open the book. Ali says, okay, remove the what you want to call it, okay, plastic covering of the book. So how many of you have tried to, yes, okay, just browse through the book to see, yes, okay, what it looks like? Okay. So far, what do you think? Okay, let's see how far, okay. Okay, guys. Okay, so yes, okay, your test, as I said, yes, okay, they are going to be multiple choice. Okay, no open written answers and so on. I don't give bonus questions. Okay, for a main reason because okay, where are those questions going to come from? From the book. So you couldn't answer that question as a regular question. Why should you be able to answer it as a bonus question? Okay, so it's straightforward. Yes, okay. Each question, yes, okay, or you can say, okay, each answer carries a point because you may have questions which come with more than one answer. Okay, but that doesn't mean that for every question you write A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. That's okay, whichever one is right, okay, I'm going to get it right anyways. No. Okay. Okay, guys. But the rest is the same. Yes, okay. After the test, well, okay, yes, most likely it's okay. Try to grade them right there, and we will go over the test again together, where you can, okay, learn from your mistakes. Okay, so let's just see if we can get started now. Is anybody and it's okay for now what you may see is okay, your book has this a lot of okay as small boxes, tables, etc., etc. Later on in it's okay, some of the later chapters was okay from chapter 3-ish, 4-ish. You may start just okay, see just okay hint boxes. Now they are already highlighted. So the main purpose of that is mainly as okay that you that they catch your attention. Okay, so most of the hint boxes, yes, okay, should be yes, okay. What we can say is okay, a must to know. Okay, or we can mainly say okay that what those hint boxes does is mainly as okay give you a hint, which is mainly as okay explaining as okay, or summarizing a thing in few words, which you can actually have written as okay paragraphs and paragraphs and paragraphs about. Okay. Now, as I said the other day, and I will say it again, you may take physics. It's okay, a lot of math, not necessarily. So although it's okay, you see numbers, doesn't necessarily mean that we need to do calculations. But mainly it's okay, just something to it's okay use as a reference. Now, the first topic that we'll be talking about in this chapter here is going to be graphs. Okay, it's going to be graphs. Now, practically speaking, yes, okay, if we take a graph, and we talked about, for instance, okay, graph in terms of ECG, where the G mainly is okay was a graph. Okay, we said EEG, but again, yes, okay, the G was a graph. Okay, okay, you can take any graph of anything. Okay, okay, which means yes, okay, going to be yes, okay, spikes or blocks or lines that goes up and down. Okay. Now, usually, guys, that's okay for any graph, or generally, that's okay. A graph is going to just okay have two axes. Okay. Now, the two common axes that we have in a graph is going to be as okay, will be as okay the vertical axis. And this vertical axis here is okay, that is going to be called the y-axis. Clear? Okay. Other axes that we will have in a graph, or most common standard axis, is going to be as okay, will be the horizontal axis. And this horizontal axis here is going to be called the x-axis. Did you guys get that?
Yes.
Okay. So primarily, yes, okay, in a graph, we mainly, yes, okay, we'll deal with, most instances, okay, we'll be dealing with these two axes here, which is going to be vertical and horizontal. The vertical axis is always going to be called the y-axis. The horizontal axis is always going to be referred to as the x-axis. And what we mainly can say here is, okay, the point where these two axes here meet. This point here. That's going to be, okay, what we can call is, okay, the 0 point. Did you guys get that?
Yep.
Good. Now, besides these two axes here, is there a third axis as well? And maybe it's okay, a little bit difficult, just okay, display here, but we can, it's okay, just go and say it's okay, it may go something like this. And that's going to be as okay, it's going to be as okay in terms of direction, is going to be perpendicular axis. And what we call this is going to be as okay, the z-axis. Okay. Now, guys, in case that we use all three axes, we use, let's say it's okay, x-axis. Plus, let's say it's okay, the y-axis. Plus, let's say it's okay, the z-axis. That gives us, okay, it's a three-dimensional. Meaning it's okay, because it's okay measurement. And this three-dimensional test is going to be as okay, what we also is okay later on recall volume. Whereas if you just take two axes, it could be the x. Sorry. It could be as okay the y. and the X. It could be the X and the Z, or it could have just been Y and Z. These three here, I mean, yes, okay, just going to give us two-dimensional measurements.
Mike, what does it say after three-dimensional? Does that add?
Two-dimensional measurements.
Thank you.
Yep, okay. So in this case, yes, okay, just to check it, we can say it's okay, X axis, for instance, is okay. Could have been, yes, okay, what we call width. Let's say it's okay, the y-axis could have been, yes, okay, the height. And the z-axis could have been, yes, okay, sorry, depth. For instance, okay, we use these three axes here to, yes, okay, measure. Okay. Now, guys, it is Christmas season. Clear, okay. You may not have time to, yes, okay, run to every store to buy packets. So what do? You may go on eBay, Amazon, Alibaba, whatever you call them, right? Okay. And order, yes, okay, things there. Let's say it's okay, you're ordering a new sofa set. So what is it that it says in the description? It will give you, yes, okay, a dimension of that sofa set. That you can say, it's okay, once assembled, it's going to be, yes, okay, this many feet wide. Clear? Once assembled, yes, okay, it's going to stand this many feet tall. Once the sample, yes, okay, is going to be the stand, yes, okay, having this at that depth. So that's going to be, yes, okay, a three-dimensional measurement. Did that make sense? So you may say, well, okay, the sofa ends up standing 7 feet wide, or yeah, wide, 3 feet tall, and 2 feet depth. Clear? Okay. And you can actually just, okay, take those measurements in the room and the place where you want to keep it. Say, would it even be practical to fit it in this part here? Whereas, okay, I may fit the sofa, but okay, yes, now I'll be stuck in the room because I won't be able to open the door. Because it takes up the area, yes, okay, where the sofa is, yes, okay, where, what is it that you're going to use to? Let's say, okay, open the door. And then you may have to climb out of the window just to get out of the room. Did that make sense? Okay. Okay. But any two dimensions, or you can say, okay, any two axes, if you only take those measurements, that's going to be two-dimensional measurements. You can say, well, okay, just the height and the width, that's all I need. Oh, yes, okay, just the depth and the width, that's all I need, or something like that. Okay, so three-dimensional measurements are going to be what we'll call volume. Whereas two-dimensional aerial measurements are going to be, as okay, what we'll call area. Yeah, okay. Or just look here, guys, because okay, explaining is okay, the z-axis maybe is okay, a little bit difficult on a writing board. So yes, okay, these are your two axes. The vertical axis was the y-axis. The horizontal axis was the z-axis. And this pen here is going to be as okay your z-axis. Okay. Or if you take it this way and say, okay, this here is your z-axis, this is the y-axis, or x-axis, and now the pen here, that's the y-axis. So this is z, this is x, and the pen, that's your y-axis. Did that make sense? Okay. Any questions? Okay. But generally, it's okay. The two axes that we may be referring to when talking in graphs is the x-axis and y-axis. Okay. So we're going to get back to these axes here, yes, okay, in chapter 11. Okay. Because there's going to be, yes, okay, different things that are going to, yes, okay, be measured along different axes. Okay. Now, just that I gave you, yes, okay, mention a chapter here doesn't mean that you should jump to chapter 11 now. But just okay, say, okay, well, this info here is going to become relevant again, yes, okay. Especially, it's okay, when we talk about, it's okay, the different axes is going to become relevant in a upcoming chapter. Did you guys get that? Okay. But what is it that we, yes, okay, in general, not necessarily for ultrasound guys, but generally speaking, yes, okay, what is it that you can use a graph for? Not in terms of ultrasound guys. Generally speaking, where and why is it that you may use a graph? Yeah, Jennifer, you want to say something there?
Just like show how one variable affects another.
Okay. Okay. Let's just do it this way. Now you may get, let's say it's okay, a big statement, right? Or bank statement, sorry. Right?
Yep.
Okay. What is it you may see on that bank statement is okay, there's going to be okay, XYZ number of dates. Clear? Okay. And on those dates, that's okay. Let's say it's okay. On each date, you may run an average of 3 to 4 transactions. So those amount of numbers of that's okay, money that was mainly that's okay, withdrawn from your bank account mainly because you ran those transactions is going to be written over here, right? Okay. Where you go in a monthly basis, when you go weekly basis or annual basis or whatsoever. Okay. But this thing here can also, as okay, be represented in a form of a graph. Okay. So this same information you have, let's say it's okay, a bank balance or a bank statement can also be represented in a graph form. So you may put it this way and say, well, okay, this y-axis here, that's going to, as okay, be the hundreds of dollars. And usually it's okay when things like that is done, it's okay, it's going to be it's okay, graduated like this. Where okay, you can see it's okay, the x-axis. Will be time. And let's just say it's okay here. The time is going to, yes, okay, we're going to measure in terms of days. Or you can say months, it doesn't matter. Or date of the month, or anything. Now, yes, okay. You might have started as okay, your bank balance with okay, 1, 2, 3, 4, 5, 6. That's it. $600. This will be $500. It makes it like $400, $300, $200, and let's say it's okay, $100. And this point here is okay, that would have been well, okay, because it's okay, that would have been $0 if you go, yes, okay, along the y-axis, and we can say, okay, day 0. Along the time axis. Did you guys get that? Let's just say that you start the whole thing with, okay, yes, $500. So on day 1, yes, okay, you had a bank balance of $500. Okay. You spent $300, yes, okay, you're left with just $200. Okay, well, okay, it was payday, so yes, okay, you got your pay, so yes, okay, now you left, okay, yes, with, that's okay, $600. But then it just goes down, okay, yes, you spend $200, like this. So at the end, yes, okay, you may have, okay, yes, bigger or taller. And okay, down here, so okay, you may go into negatives. But what you actually have here is, okay, as a graph of, let's say, your bank history over the span of time. Yes, okay, how much money is it that you have? Did you guys get that?
Yep.
Right, okay. Okay, now guys, if we, for instance, okay, look at this graph here. Now let me just do it this way and say, well, okay, here. Oh, this point here, that is the 0 point. All of your axes. Yeah, okay. Now we may have, yes, okay, the y-axis, which is vertical. Well, let's just do it this way. This is your y-axis. You can also say, yes, okay, we may have, yes, okay, the x-axis. Which is horizontal. Did you guys get that?
Yeah.
Okay. But this point here, that is your 0 point. Now, guys, that's where we mean you can say it's okay that okay as our x-axis, which is okay as this pale blue or pale green. That is going to be positive. Where okay as the part of the x-axis, which is dark green, is going to be negative. Likewise, that's okay. We go for the y-axis. This light blue here is going to be the positive of the y-axis. Or whatever Cauchy or okay factor or number or whatever is represented along the y-axis. Yeah, okay, it's our dark blue is going to be negative. Okay, because we said that okay, this black point here, that was the 0 point. So we could say okay, we said that was the 0 point along as okay the y-axis. Anything that will be as okay greater than 0 will be a positive number. Whereas anything that will be as okay lesser than 0 can either be negative. And what we will mainly as okay, we'll see that okay, these negatives here most likely as okay, as far as we are concerned, are going to as okay be expressed as decimal numbers or fractions. Did you guys get that?
Yes.
Yeah, okay. Okay. Now, likewise, as okay, we say that let's just take that okay as let's just assume that okay as the factor is okay expressed along the x-axis. Let's just say it's okay that the factor we expressed along the x-axis was time. Yeah, okay. So what would this okay, this 0 point here be, for instance? 0 point would have been yes, okay, year 0. Okay. But we now can say as okay, this all here is okay, that will be as okay, what we call 80. Right, okay. So right now we are in as okay 2023-80, right? What do we call the time before year 0? That would have been BC, right? Did that make sense?
Yeah.
Clear? Okay. Okay. But likewise, okay, even is okay on anything is okay, which is going to be on this side here of your 0 point can be as okay as far as we are going to be concerned is going to be as okay either a fraction, which also can be as okay be represented as a decimal number, which still are going to be negative factors. Okay. So it all depends upon us, okay, where we are. Is okay, determined by us, okay, what criteria is going to be as okay, what parameter or factor is going to be as okay expressed along what axis. But on a graph, that we said, okay, yes, this is the 0 point. Greater than 0 is always going to be positive. In direction-wise, okay, this will be as okay greater than 0. So this is also going to be positive. Whereas, okay, on the other hand, we can say it's okay, less than 0 would be negative. And we can say it's okay, less than 0 here is okay, will be negative. Okay, but these negative values here are always as okay are going to be as okay described as a decimal, which also as okay can be expressed as a fraction. Now we'll talk more about that when we get to yes okay what we call units. Did you guys get that? Okay. So anything that is less than 0, that's okay. Your bank balance gets less than 0. You say that okay, it is in the negative, right? Okay. Now the first $200 that you may put into the bank is just going to bring it back from minus 200 to 0. And anything more than those $200, then now your bank balance may become positive. Did that make any sense? Okay. Any questions about the graphs right now? Okay. Anybody want to say anything? Hey guys. If that's the tempo, then we will be finished with this thing here before Christmas. Your final may be as okay on the 22nd of December. So guys, the more you ask, the more you learn. Okay? That's fine. This is just the basics. Now, guys, 90% of your ultrasound physics is going to be based on the following points that we talk about. Relationships. Okay. I said the other day, I will repeat myself that yes, even though you see numbers in a question, you may not have to necessarily do the math. But mainly just understand the relationship between the factors whose values have been given. Is that clear? Because that's pretty much what you will be asked about. Okay. But before understanding how factors are related to one another, because that's something that will come up as we start talking about different factors individually, and then try to relate them to other factors or parameters or whatever you want to call them. Okay. So let us just understand how is it that we understand what we can call relationships. And what is that they would mean. Okay, guys? So let's do it this way here. as far as relationships are concerned, we can have two kinds of relationships, basically. The first one is going to be as okay, we can say as okay, unrelated. The second one is going to be related. Did that make sense?
Yep.
What I mean by
Yes.
being unrelated is, well, okay, yes, whichever factors we are talking about, is okay, they are not related to one another. Is that clear? Did that make sense?
Yep.
Yes.
Now, what it does mean that, okay, yes, when two factors are not related is that, okay, yes, the main take one point is that, okay, yes, we can say, it's okay, that one of the factors will not, because it's okay, change, or we can say it's okay, affect the other. Okay. Now we can take some weird examples of things which are not related. You can say, it's okay, your age is not related to the color of the shirt that you're wearing. If that was true, then areas, okay, people in their 20s will be wearing blue, in their 30s will be wearing green, in their 40s will be wearing so and so. Okay, so that's completely as okay, unrelated. Clear? Okay. Did that make sense? Okay. You can say as okay, the amount of shopping that you do is unrelated to the bank account of your neighbor. Okay. You can go on a shopping spree, well, okay, that's not going to affect his or her bank account. It will affect yours, right? But not the bank account, the bank balance of your neighbor. Not if he or she goes on a shopping spree, well, that's not going to affect your bank account unless they got a hold of your credit card and PIN codes. That's a different story then. Yeah, okay. But you can say, okay, well, so what does that mean that, okay, yes, that factors are unrelated? Well, first of all, they are not associated with one another. But the main bottom line here is that, okay, as changing in one factor is not going to affect or change the value of another factor, because these two factors here are not related to one another. Did you guys get that? Okay. Now, as we go through questions, you may see that, okay, they may label as, okay, one thing as A, the other thing as B. Clear? Okay. Now, if A and B are not related, you may as okay increase or decrease the value of one of them is not going to have an effect on the other or the value of the other one because they are not related to one another. Did you guys get that? If not, well, okay, yes, we can just do it and see it's okay what we meant by it's okay being unrelated. Just a way, it's okay. An example, we can say it's okay. We have two things. One is referred to as A. One is referred to as B. Clear? Now let's just say it's okay that we start off with A as 20. He says, okay, the value of A is 20. And we can say, okay, the value of B is, just to keep it simple, yes, okay, it's 20 as well. Okay, but mainly it's okay because now here it's okay, these are not related. They may say, well, okay, if we increase the value of 20, of A, sorry, from 20, yes, okay, it's going to be changed to, let's say, it's okay, 80. What we get from this here is, okay, that the value of A actually is, okay, increased 4 times, right? Clear?
Yep.
Good. But guys, since here is, okay, A and B are not related, and they may ask us, okay, what is going to be the value of B after we increase the value of A? Well, it will still be 20 because it's not really affected by the change in the value of E. Why? Because A and B are not related. But the same can go with S, okay, B, S, okay, change in B. You can just, okay, let's just say it's okay that we reduce the value of B to, let's say it's okay, 1/4. 1/4 of 20 is 5. But what's going to be, it's okay, the effect on the value of A? Well, A will still remain 20, although it's okay, B was reduced to 5 or reduced to 1/4 because A and B were not related. So guys, the bottom line is two factors or parameters which are unrelated. The change in one will not change or affect the value of the other. Did I make myself clear on that one?
Yes.
Okay. Now the main challenge as we proceed through this course here is to be able to just, okay, figure out which factors are unrelated. Did that make sense? Which factors will be unrelated? Because, okay, changing the value of one of the factors will not change the value of the other factor because they're unrelated. Or who is planning to buy a new car? Let's say you have your eyes on a car. Assume you have your eyes on a car, or you say, okay, this is going to be, okay, my new car, the new model, the new make, and whatsoever. Now, let's say it's okay, right now, it's okay, it's market value. They say, well, okay, right now it costs 20,000. That's going to be, okay, the price of the car. Clear? Okay. Now, let's say it's okay, you have 40,000 in your bank account. Okay. Now you say, okay, how is that going to become unrelated? Well, okay, the price of that car may go from 20,000 to 80,000. been increased 4 times overnight, right? Well, how is that going to be related to your bank account? It's not related. Because your bank account is okay, may is okay, just have a change of balance of $2,000 in either direction. Or still maybe at 20,000. Let's just put it that way. So it's because that value of that car that you had your eyes on went okay as it's okay, increased its value 4 times. Didn't affect your bank balance. Or let's say it's okay, has no effect on it's okay, the color of your shoes that you're wearing. Okay. You can say, okay, shit, okay, yes. And I actually, yes, okay, make up, yes, okay, increase my bank balance 4 times to be able to buy it. Any questions? So that's because, yes, okay, they were unrelated. There was no link between the two. So this is one of the relationships that you have to be, yes, okay, a little bit, yes, okay, in the top out because, yes, okay, although, yes, okay, you may be asked about possible relationship between factors, doesn't necessarily mean that they got to be related. So the bottom line is that's okay, just because the value of one factor increases is not going to affect the value of the other factor. That will remain the same. Just because one factor either increased or decreased. Did that make sense? Okay, guys. Anybody have any questions? Now let's just go back. Because, okay, the other kind of relationship that we had was that factors could be related. Okay. Now, what your book may also, yes, okay, use is that, okay, yes, the word for relationship can also be, yes, okay, proportional. Is that clear? So it's okay, we may say it's
Yep.
okay, related or proportional. Now, as far as things being related are concerned, yes, okay, there are 2 major subtypes of being, yes, okay, related or proportional. One is going to be, yes, okay, what we'll call, yes, okay, either directly related. Or we can say it's okay, directly proportional. Is that clear?
Yep.
Good. The other kind of relationship is going to be as okay, what can be called inversely proportional related or inversely proportional. Does that make sense?
Yep.
So these are the two main types of relationships, which either can be referred to as being directly proportional or directly related, or inversely proportional or inversely related. Now let's just say, for instance, okay, let's say, okay, as for directly related, what does that mean? And let's just say that, okay, yes, let's just go on to this fellow here. And say it's okay. Now let's say it's okay that we says, okay, first of all, it's okay, we are going to be related. What kind of relationship is going to be as okay? Directly related. And for instance, okay, we had two factors. We could say it's okay, we have factor A, and we can say it's okay, we have factor B. Is that clear? Okay. Now, as far as okay as the value of factor A is concerned, let's say it's okay that we started off at 20. Clear? Okay. Just to keep it simple, yes, okay, the value of factor B as well, yes, okay, also, yes, okay, start at 20. Now we say that, okay, these two here are, okay, yes, going to be, let's first, that's okay, talk about is, okay, related. That mainly mean that, okay, as any change in the value of A, whether that is increasing or decreasing, is respectively cause a change of increase or decrease in the value of factor B. Yeah, okay. Because we change the value of A, and A is related to B, as okay, the value of B is also going to change. That's what we established by as okay saying that they were related or proportional. Did you guys get that?
Yep.
Good. But what is that going to be as okay, the meaning of being as okay directly proportional? That mainly mean that okay, yes, if the value of, let's say as okay, A increases, that's going to lead an increase in the value of B. Did you guys get that? Whereas if we said, okay, the value of A decreases, well, that will also lead to, yes, okay, a decrease in the value of B. Did you guys get that? So that's mainly because, okay, the relationship between, okay, these two factors here was directly related or directly proportional. So the easy way to remember is that directly proportional is if thumb is up, thumb is up. The value of this hand here is equal to okay, or okay, or is related to the value in this hand here. So if this increases, this will increase as well. If that makes sense. A very simple, straightforward example, you can say, okay, the amount of hours that you work is directly proportional to, okay, your paycheck. Let's say it's okay, they pay you by the hour. Clear? Okay. You work 20 hours, that's okay, your paycheck may be 20,000. Yes, okay, if you work 80 hours, your paycheck will be 80,000. Because for each hour you earn $1,000. What a job. Right, okay. Okay. But you can immediately say, so what is that? You're going to say, well, okay, yes. First of all, yes, okay, is my pay check going to be related to my hours of work? Yes. There's a relationship between those because you can say, yes, okay, the more hours or less hour you work, the more or less is it that your paycheck is going to be. So yes, okay, one increase, the other will increase. Okay. Where, okay, is if one decrease, then the other will decrease. Because they were directly related. Whereas, okay, if they were not related, then, okay, yes, let's say it's okay, you work on, okay, as a fixed amount. Whether you work 5 hours or 50 hours or 500 hours, your paycheck is $5. That because, okay, the amount of hours that you were working was not related to your paycheck. Because one was kept fixed. So you could be doing nothing and still get, yes, okay, your paycheck or whatever amount. Or you could be working your AWS off. Yes, okay, just getting that. That's okay, allows the paycheck. Okay. But here, yes, okay, you say, okay, the more hours I work, that's okay, the greater will be my paycheck. Okay, good. The less hour I work, that's okay, lesser will be the paycheck. So that's okay. In holiday season, you probably that's okay, will like to just okay, do some little overtime, right? Okay, because you may need the money for the gifts, for the extra groceries, for that's okay, the Christmas dinner or whatever. Did that make any sense? So that's what you mean by it's okay being directly proportional or directly related. Clear? But please keep in mind, guys, that okay, yes, if it is one increases, the other will increase. How much this increase will lead to us, okay, how much increase in this, that is not relevant. Clear? Okay. You may say, okay, one increase, the other will increase. One increase, one will increase. Well, okay, if they go on a decline, decreasing, yes, okay, mainly because they were still directly related. Or one decreases, the other will decrease. One decrease, the other will decrease. So that relationship is called directly related or directly proportional. First of all, yes, okay, relationship is there because, okay, change in one factor is going to, yes, okay, affect the value of the other. But when we say, yes, okay, directly, yes, okay, one increases, then the other one will increase too. Clear? Okay. Whereas we say, okay, one decreases, well, okay, it's going to affect this one here. But that's when it becomes directed, you say, okay, this is going to decrease as well. Because they were both directly or proportionally or directly proportional or directly related. Did you guys get that? Now, is there anybody who has any questions? So that was our first relationship. Or where we can say it's okay, where things were related. Clear? Okay. So increasing one increases the other, decreasing one decreases the other. Any questions?
Nope.
Good. Now, guys, our other relationship is going to be, it's okay, what we can call it's okay, either inversely related or inversely proportional. Yeah, okay. Now, guys, again, now we say it's okay. First of all, it's okay. They were going to be it's okay related or proportional. Yeah, okay. Which in this case, yes, okay, still will mean that okay, yes, a change in the value of A will lead to a change in the value of B. That we can say as okay. If A increases, that may lead to as okay, either an increase or decrease in the value of B. Likewise, as okay, B decreases or A decreases, that might have led to as okay, an increase or decrease in the value of B. That is based on as okay, that's because they were related. But become everything, oh, it means it's okay, going to say, okay, what does it actually mean? It's okay, be inversely related. Now, the inversely related thing here actually will mean that, okay, yes, we can say it's okay. Now, let's do it this way here. That if A increases, that actually will cause that the value of B will decrease. Or if on the other hand, we say as okay, the value of B decreases, will actually lead to as okay, an increase in the value of B. That's what we mean by being inversely related. Or we can mainly say it's okay. The reason that this happens is because it's okay, the relationship between A and B is inversely related. That if A increases, that will lead to, yes, okay, a decrease in B. Because A and B were inversely related. Or if B decreases, or if A decreases, for instance. That will lead to, yes, okay, an increase in B. Because A and B were inversely related. Or as we may go, yes, okay, with our thumb rule. And say, well, okay, whatever factor we have in this hand here, if that increases and is related to the factor that we have over here, okay, an increase in this is going to just, okay, cause some change in the value of this factor here. But that change is going to be as, okay, a decrease because these two factors here were inversely related to one another. Did you guys get that? Oh, yes, okay, the other way around. So by saying that, okay, as two factors are inversely related, mainly will mean that increase in one will lead to a decrease in the other. Or decrease in one is going to lead to an increase in the other. Because they are inversely related. Did you guys get that?
Yes.
Okay. So how can you relate that? You can say, well, okay, bank balance is inversely related to amount of money spent. Okay. The more money you spend, what's going to happen to your bank balance? It's going to, yes, okay, decrease. Did that make any sense? Clear? Okay. But the basic thing about, yes, okay, being inversely proportional is that if one factor increases, the other factor will decrease. All like this. Okay. So the main thing that we will, yes, okay, try to figure out as we proceed through the course is which factors are going to be as, okay, inversely proportional. Or let's say as, okay, inversely related. Clear? Okay, but that can only be in case that there is a relation between those two factors. That's the first thing that you got to establish. These two factors here that I'm being asked are 3 or 7. Are they related to one another or not? If they are not, then the change in any of the factors, okay, let's say, okay, one factor is not really going to affect the other one because they were not related. Did you guys get that? Clear? Where you come on to the sideways, okay, things are related. We can say, well, okay, they are going to be as, okay. What does it mean to be related? That change in one may as, okay, cause a change in the other. That's because they were related. Or when that change in one is increasing, it's going to cause a change of increasing another. That's because these two fellows here were directly related. Likewise, that's okay if this one is decreasing and the other one here is also decreasing. That's going to be because they are still directly related. Did that make sense? So this is directly related. This is directly related or proportional. Clear? Whereas if we go on the other hand and say, well, okay, yes, these two factors, yes, okay, they are still related, which mainly mean that, okay, a change in one is going to, just, okay, lead to a change in the other. Right, okay? But when that change is as such that increase in one factor leads to a decrease in the other factor, that will be an inversely proportional between an inversely relationship, or we can say, okay, that these two factors here were inversely proportional to one another. Clear? Okay. But on the other hand, we can say, okay, it will be the same factors, but if this one here decreases, then this one here will increase. That's because, yes, okay, these two are still inversely related or inversely proportional to one another. Did you guys get that? Okay. Now just take a short, should we say, it's okay, 15 minutes break, and when we come back, we will talk about a subtype of being inversely proportional, which is going to be reciprocal. And a relationship that we'll be dealing a lot with. Okay. So I will see you guys back at, should we say, 10:40-ish. Is that clear? Okay, guys. Have fun till then. Hey, guys. Welcome back, guys. Now, any questions? Any questions at this point? So you guys are
No.
good. Okay, you guys are good about axes, XYZ. Good. You guys are good about the relationship that we have talked about so far. Good. And what we have said was this is directly related. This.
Here's what I found.
No, you don't need to find anything. Sorry. Sorry. This and this is inversely related or inversely proportional. Is that clear? Good. Now, guys, when we talk about things being inversely proportional, what did we say? It's okay that if one increases, the other decreases. Clear? Or one decreases, the other will increase. That's pretty much okay what we meant by being as okay, inversely proportional. Okay. Okay. So 4 factors that are inversely proportional. We can put it this way that okay, that inversely proportionality can be further specified or further clarified because what mainly is okay meant to be as okay inversely proportional One may increase, the other one will decrease. Okay? This may increase 100 times, and this one here may just decrease to 1/10. Or this may increase 10 times, this may decrease 100 times. Yeah, okay? That was not specified. Okay, the only thing that we said about okay is when one increases, the other decreases, that's being inversely proportional. Okay. But when talking about being okay, inversely proportional, yes, okay, guys. There's a subtype of relationship in that case that is going to be okay, what we'll call reciprocal. Okay, guys. So please be clear about that. It's okay. Whenever we talk about something is okay being reciprocal, there is no question about it. Is always going to be okay inversely proportional, or what we also can call it okay inversely. I'm sorry, inversely related. Is that clear? Did you guys get that?
Yeah.
Good. So let us just go on to yes, okay, to let's see if this way here. See. Now we say it's okay. First of all, it's okay if something is okay was inverse related. Okay, and we had okay as two factors. We says okay, factor A, factor B. Was mainly meant that okay as or mainly as okay made them inversely related. Was if we said that okay as if A increases, then B decrease. Or if B decreases, A decreases, sorry, then B will increase. These mainly as okay just stated that okay as due to that as okay, mainly we said that A and B were inversely related or inversely proportional. Did you guys get that?
Yep.
Good. Now, what it mainly will mean that okay has to be inversely related. And yes, okay, when it says okay inversely related, and on top of that is okay, B is okay, what we can call reciprocal. Let us just put it this way here and say it's okay. Sorry. Let's say that okay, yes, we have A. And for instance, okay, we have B. Now, just for the simplicity's sake, it's okay with me. Say okay, yes. That okay, yes, we take that okay, the value of A is going to increase, which mainly will mean that okay, the value of B will decrease. Yeah. So that mainly as okay meant that okay, as A and B were inversely proportional or inversely related. But when we say here, for instance, okay, let's say that okay, now just okay, establish that okay, it's not only are A and B inversely proportional, but it's okay on top of being inversely proportional, they actually are going to be as okay reciprocal. And we say that for instance, okay, the value of A, for instance, okay, increases 10 times. Yep. That will mainly mean that okay, the value of B is going to just okay decrease to 1/10. Because A and B in this case here were reciprocal. Just to take a simple example, guys, not to make it as okay too complicated. Let's say it's okay to start with as okay, the value of A was 20. And we can say it's okay, the value of B was 20 as well. or B, sorry, was 20 as well. Okay. Now, what we did was we said, okay, that we increase the value of A 10 times. So what's going to happen to the value? It goes from being, it's okay, 20 to become 200. Did that make sense?
Yeah.
But as we increase the value of A 10 times, the value of B is going to decrease because A and B are inversely proportional. Okay. But how many times? Mind that's okay, what is going to be as okay, the reciprocal of 10, which is 1 over 10. Okay, so what is actually going to happen here is that, okay, yes, that 20 is going to, yes, okay, reduce to, yes, okay, 1/10. And we can make this as, okay, as a result of that, is okay, the final value of B will be 2. Okay. Now, how do we know that, okay, as the value of B is going to, yes, okay, be 1/10? As okay, decreased by 1/10 when the value of A was increased 10 times. That's mainly because 10 and 1/10 are reciprocal. So you can pretty much take any number and say, it's okay, then what about 22? What is going to be the reciprocal of 22? Sorry. That's going to be 1 over 22. You can say it's okay, 50. So what's going to be the reciprocal of 50 is going to be 1 over 50. Is that clear?
Yeah.
Good. Okay. So what it actually is, okay, means to be reciprocal is, well, okay, something like this. And another thing that LKS is going to confirm that something will be reciprocal is that, because it's okay, the product of the two equals to 1. Which two? The reciprocal numbers. Which may be that we can say, okay, now what do we mean by the product? That may mean that, okay, as they are both multiplied. Okay. What I be multiply as, okay, the number it is reciprocal. So you can maybe say, okay, that 10 multiplied by 1 over 10 actually becomes as, okay, 10 multiplied by 1 divided by 10. And you can do it the long way and say, it's okay, 10 multiplied by 1 would be 10 divided by 10. Like this. You get 1. Or straightforward as, okay, without doing any multiplication, you just cut out these two here. That's okay, what do we have is 1. But let's just take this one here. We say that's okay, 22. The reciprocal of 22 is going to be as, okay, 1 over 22. Which mainly cause, okay, this becomes equal to, as, okay, the same as 21 multiplied by 1 divided by 22. Now you can do it this way and say, okay, this cuts this, and 1 times 1 is 1. I mean, it's okay, they cut out one another. And what you have left is 1. Or you can do the math and say, it's okay, 22 multiplied by 1 is still 22 divided by 22. The product is 1. So what did it mean to be reciprocal? that if one factor increases 10 times, the other will reduce to 1/10. If one factor increases 100 times, the other will reduce to 100. If one increases 1,000 times, the other will reduce to or decrease to 1,000. But you can say, okay, one factor increases 5 times, the other is just going to reduce to 1/5. Clear? So the increase in one factor is going to be equal and opposite to the decrease in the other. Okay. Now here, yes, okay, guy, we say, okay, the reciprocal of 22 was 1/22. We said the reciprocal of 10 was 1/10. We said the reciprocal of 50 was 1/50. So this 1/10, 1/50, 1/22 was just as okay expressing the reciprocal values of our actual numbers in forms of fractions. Because 1/a certain number is going to be a fraction. Did you guys get that? But these fractions here, yes, okay, can also be expressed in decimal numbers. Because what is that? What does it mean to have a fraction? It's just a part of the whole. Do you guys know what a whole number is? Can anybody give me an example of a whole number?
Like 5.
Okay. Any other whole number?
Just like anything that's like a regular number that's not a decimal or negative.
Exactly. Those will be whole numbers. So you may just, okay, just start counting from your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No fractions, no decimals. Clear? Did that make any sense? Now you may say it's okay, 1.5. Well, the 1, that's a whole, but then the 0.5, that becomes a fraction, or in this case, yes, okay, a decimal. Clear? But then, yes, okay, 1.5 is not a whole number anymore. It is actually, it's okay, a fraction. Hey, guys, so we could say, yes, okay, we said 10. The reciprocal of that could be, yes, okay, 1/10. But this way is okay, we express it as a fraction. This fraction here, 1/10, can also, yes, okay, be expressed in a decimal form, which is going to be, yes, okay, 0.1. And we can say it's okay, either of these two here, when multiplied by 10, becomes 1. So 10 is this also, okay, so 1/10 is the same as 0.1. And okay, when both of these is okay, when either of these is multiplied by 10, it becomes 1. Clear? Okay. So both of these here are reciprocals of 100, 10, sorry. We can take another one and we say that's okay, we for instance, that's okay, had 50. Now the traditional that's okay reciprocal of that is going to be that's okay 1/50. Clear, okay. Now the decimal form of 1/50 is going to be as okay 0.2. Okay. So this means okay, both of these here is okay, were reciprocals of 50. But this here is just expressed as a fraction. This here as a decimal. But why is it that both of these is okay here or just okay are worth the same? It's because okay, when we multiply by this fellow here, it's okay, the product is still going to be 1. Multiply 50 by 1/50. Well, okay, we did it earlier. It becomes 1. Multiply 50 by 0.2. The product is going to. Did you guys get that?
Yeah.
So it's correct to say that, okay, yes, the reciprocal of 50 could be as okay straight for 1/50, or it could be as okay 0.5 or 0.2, sorry. Although as okay, this may be the more as okay traditional way, but as okay, when you look at it numerically, 1/50 is the same as has the same worth as 0.2. So both of these here are reciprocals of 50. Why? Because okay, if you multiply this by 50, the product is 1. If you multiply this one here by 50, the product is still 1. So you can mainly as okay, just go on and say it's okay 100. The reciprocal of that is 1/100. If you want to express that as a decimal, it's going to be 0.01. Now we can go to 1,000. The reciprocal of that is going to be as okay 1/1,000. Or 0.001. Clear? Okay. Now we may as okay, and as okay in physics, mainly as okay because we may as okay be dealing with big numbers. And or as okay, small fractions. So what you guys will see that we mainly as okay we'll be doing, probably not necessity for 100, but as okay, it's always worth saying it. Okay, as this 100 can actually as okay also be written as 10 multiplied by 1 multiplied by 10 raised to the power 2. Where the reciprocal of that is just going to be as okay 1 multiplied by 10 raised to the power -2. This 1,000 here can also be written as okay as 1 multiplied by 10 raised to the power 3. Where either of these, which are the reciprocals of 1,000, could also be written as 1 multiplied by 10 raised to the power -3. Okay. Very meaning can say it's okay that this minus here of the exponent is mainly it's okay because these are fractions or decimals. How big or how small? Yes, okay, 1,000, 100, a 50th, a 10th. Now, if you want to, yes, okay, be difficult, we can also write this 10 here as 1 multiplied by 10. Where here is okay, this exponent is okay here. This 1 over 10 or 0.1 can also be written as okay, 10 raised to the power minus 1. You may write a 1 here, that's fine. It's not going to make much of a difference. Because what this actually is, okay, what this means is 1 multiplied by 10. What this field here actually means is 1 multiplied by 10. And since we is okay, have an exponent of 2, which means it's okay, multiplied by 10. So 1 multiplied by 10 is 10. Multiplied by 10 is 100. If you go to the 1,000, you can mean it says, okay, 1 is 1. The 1 is 1. By here, you mainly will see that, okay, yes, multiply by. Now we can just say it's okay. 10 becomes, it's okay, multiply by 3. Which mean that, okay, yes, it's multiplied by itself 3 times. You can mean it says, okay, that these here actually means this. But if you go and say, yes, okay, 1 multiplied by 10 is 10, multiplied by 10 is 100, multiplied by 10 is 1,000. But over here is okay, you can say, what does this here mean? This mean is okay, means 1 multiplied by 1 over 100. Or 1 multiplied by 0.01. Why fraction or why decimals? Because of our negative exponent. So even yes, okay, this one here could be yes, okay, the reciprocal of 100. Or even this thing here is okay, could be reciprocal of 1,000. Because guys, that's okay, what you realize is okay, when we go further on, it's okay, when we start talking about units. Okay, there we go, yes, okay, may go to, yes, okay, things such as millions. So yes, okay, this is going to be yes, okay, a lot of zeros to start to count on. So maybe yes, okay, to simplify this, million can also be written as 1 multiplied by 10 raised to the power 6. That would be okay, how you scientifically arrive 1 million. But if you go and it's okay, I mean 1. This 10 raised to the power 6 here actually just means 10 multiplied by 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 10. There you go. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1,000,000, which is 1 million. Whereas, okay, if you go into a millionth, it's going to be a reciprocal of 1 million. That's going to be, okay, that's 10 raised to the power minus 6. Where this means, okay, will just be the same as 1 over 1 million. Or you can write it in a decimal form as this. Did any of that make any sense?
Yes.
Okay. So what would I mean? That, okay, as 2 factors which are reciprocal, one may increase 1,000 times, the other is going to decrease to 1,000. Why decrease? Because they were inversely proportional. Why would one decrease to 1,000 once the other increased to 1,000 times? Was because they were reciprocal. So you can mainly say, okay, reciprocal mainly means that, okay, the more one increase, equally but just oppositely is going to be the decrease in the other factor. Is that clear? Okay. Now maybe a little bit too early, but okay, yes. It's okay. It can only be late. It can never be too early. This kind of inversely proportional relationship that we actually, when we call as, okay, reciprocal, is a relationship that we will come across again and again and again and again and again. Is that clear? And guys, what you guys will realize is it's basically, it's okay, the same relationship between 2 similar factors. But those 2 similar factors will just be taken in different contexts. Okay, so we'll start talking about that, yes, okay, from chapter number 3. But that similar relationship is going to, yes, okay, between those 2 factors, just in different context, which will appear again in chapter 4, appear again in chapter 7, again in chapter 12, not 13. Same relationship, just in different context, and okay, yes. But if you knew it back then that, okay, yes, they were inversely proportional, not only inversely proportional, more correctly said, reciprocal is just going to be a matter of copy and paste. Do you guys know that? How to copy and paste? Yeah, okay. If an old man like me know how to do it, yes, you guys should be able to do it as well. I'll be more better in it than me. Right, okay. Yeah, okay. So you can say, okay, what is going to be a reciprocal of any number? well, okay, as just 1 over that number. But what if I say, what is the reciprocal of 1 over 26? Would that be 1 over 26? No. Then what would it be?
26.
26. Clear? Okay, because the main thing that okay has made things reciprocal was that when we multiply those two numbers, the end result is 1. Did that make any sense? Okay. Now I'm not going to be any hole and say, well, okay, what's going to be the decimal value of 1 over 26? Okay. Okay. But is there anybody who can tell me, yes, okay, where is the decimal value of 1 over 25? You have a number 1 over 25. How will you express that as a decimal?
0.25.
No. Not the reciprocal. Of course. Okay, let's write it down, guys. So you have it. Okay, says okay. 25, right? Right there?
Yeah.
Good. Now the reciprocal of 125. Of 25, sorry. Or B is okay, 120 over 25. But this fellow here is okay, that is expressed as that's written as a fraction. But how would you just okay write 1 over 25 as a decimal formula? Where is going to be 0 point something.
Point 0.04.
Exactly. Who was that?
Teresa.
Exactly. Because if you multiply 0.4 by 25, your result is 1. Yeah, just the other way around, yes, okay. 0.25, which is what we is okay. Some of the currency will call a quarter. You have 4 quarters. You have $1, right? That's okay. This 0.25, yes, okay, could be written as 0.25 as a decimal. Or in a fraction form, yes, okay, you can write it as 1 over 4. So were we correct to say that, okay, 0.4 is the reciprocal of 25?
It's actually 0.04.
Oh, sorry, it's okay, sorry. 0.04. Yeah. Right, okay. Because, okay, when we multiply them, it's okay, they become the product is 1. Or if you multiply, it's okay. It's by 25. Here's straightforward, okay, they mean it's okay, just cut out one another and you have the product 1. Clear? So the main thing about SOK being reciprocal is when you multiply 2 numbers together, the result is 1. A fancy word for saying SOK multiplying 2 numbers, which may be used is that the product of those 2 numbers is 1. Yeah, okay, so that's just okay as a word for SOK. Or we can say SOK, the grammar of mathematics. The product of these is so and so. That may mean that okay, as when we multiply these numbers. The sum of these numbers mainly as okay means when we add the numbers. And the difference of these numbers here is when we subtract the numbers. Okay. So those are made as okay, just for we can call as okay the grammatic words for multiplying, adding, and subtracting. Product, sum, and difference. Yeah. So saying that the product of numbers is 1 is mainly mean that okay, when we multiply these numbers, the result is 1. Did you guys get that? Okay. And once we said reciprocal, there's no question about it that okay, yes, 1 increases and the word decreases. Because the fraction part, if it says okay, the reciprocal of 10 was 1/10. Main indicator, okay, that 1/10 mainly means that okay, as it decreases. Obviously, it's okay, 25 reciprocal of that, 1/25. Obviously, 100 reciprocal of that, 1/100. Because one is increased, the other one will decrease. So there's no question about it. Okay, when things are reciprocal, they're always going to be inversely proportional. Did that make sense? That's how you kill 2 birds in 1 stone. So if something is written that, okay, yes, are known to be inversely proportional, but is also known to be reciprocal, and you have option A and option B and option C. But we know that, okay, this factor and this factor here are reciprocal. Then the option that says reciprocal is going to be the answer. Because factors can be inversely proportional, but not necessarily reciprocal. And they're just inversely proportional to one another. That makes sense. But factors which are directly related, well, okay, they cannot be reciprocal. Because in that case, okay, they will both increase together or both decrease together. That's what we called being directly proportional or directly related. Clear? Okay. But the reciprocal value of any whole number can be expressed as a fraction or as a decimal. And or if you go into it's okay, big or smaller, it's okay, those scientific exponent expressions. So and so multiplied by 10 raised to the power whatsoever. Where that raised to the power mean is that's going to be okay. How many times is it that you multiply 10 by itself? You say 10 squared, that just means okay, 10 squared is 10 multiplied by 10. 10 3 or 10 cube is 10 multiplied by 10 multiplied by 10. So let's go on. 10 raised to the power 6 would mean 10 multiplied by itself 6 times, which makes a million. Whereas you go the opposite way, it says, okay, 1 over 10 raised to the power. Or we can say, okay, 1 multiplied by 10 raised to the power minus whatsoever. That minus factor actually indicates that we are talking of a fraction of the whole, which also can be as okay a decimal. But so far, are you guys good upon the relationships? So what did it mean to be unrelated? Well, okay, whatever you do to this number here is okay, it's not going to affect me because I'm not related to it. Okay. You can bang this guy as okay as many times with a baseball bat in his head. It's not going to affect me because okay, I'm not related to that dude or chick. Unless okay, as the human instinct wakes up and say, well, okay, I may not have a blood relationship, he may not be a brother, a sister, an uncle, a niece, a nephew, or something like that. Well, it's okay, at least it's okay as a human, it's okay, I may be considered as okay related to this person here. So it's okay, enough is enough. Okay. 2 bangs in the head of this guy here is okay, or chick okay, with a baseball bat, that was my limit. That's conscious, okay, well, okay, we may not be blood related, but it's okay, I say this is enough. Now hitting her or hitting him is going to just okay be like okay, hitting me and okay, yeah, okay. Well, that's okay. If not, then you can say okay, it doesn't affect me. Or it's okay, whatever changes here is not going to affect the other one because they were unrelated. Now, when you say it's okay, the related was mainly is going to be directly or inversely. Okay, don't get confused by the term proportional. If you look at the word proportional, it's just okay, pertaining to proportion. Okay. Now, what would be an easy example of okay explaining as okay proportions? You can say, well, okay, my recipe tells me it's okay how to make it's okay cookie for 10 people. But if I'm only going to get 5 people in for it's okay whatsoever to get together. Okay, the proportions will actually tell you that's okay, or actually be a way by which you'll be able to calculate, well, okay, how many eggs do I need? Although the recipe here, our recipe says say 10 eggs, but that's for 10 people. If I only want to make cookies for 5 people, I will only need 5 eggs. Clear? Okay. So that's the proportional part. Which you can say is okay, mainly as okay, I mean as okay relation. Did that make sense? So when we say directly, well, okay, yes, this side increase, this side increase. Clear? Okay. The recipe may only be for 5, 10 people, but you're having as okay 100 people. Okay, then you need to increase it accordingly, or relatively, or proportionally. Clear? You have 25 people coming in. Well, okay, yes, you may just need to just okay 25 eggs. So that's the proportion. That's the relationship between is okay the recipe and okay you can say okay the number of eggs that you may need, all dependent upon how many people are coming in or how many cookies is it that you intend to bake. Did that make any sense? Well, okay, as if you go on the opposite side and say, well, okay, things which are inversely proportional. That may mean that, okay, I say one increases, the other one will decrease. That's just how it goes. Whereas, okay, we quantitatively, as okay, specify that change is going to be reciprocal. And there's no doubt about it, reciprocal is always going to be inversely proportional. However, it says, okay, one increases 10 times, the other is going to reduce to 1/10. 50 times, 1/50. 100 times, 1/100, and so on. May increase as okay 1,000,000 times, this will decrease to 1,000,000. Did you guys get that?
Yes.
So things can be, yes, okay, please. Things can be inversely related, but not necessarily reciprocal. Is that clear? Good. Now, okay, guys, what you have on page number 4 are some questions. Now, what you may find, as I said, is okay the other day, right next to the question are the answers. But the correct way of okay is answering those questions is cover up the answers. Try to answer the question and then just verify it by the answer written right next to it. Okay. Now just take, let's say, 10 short minutes to just okay, do these questions here and verify them. If not, well, okay, yes, you have some relations to look on. Okay. And okay, as when we come back, we can ask, okay, maybe it's okay, just try to just okay, go over them together. Okay. So we'll see you guys in 10 minutes. Okay, guys. Any questions yet? Did you guys try to go over the questions? Okay. Any confusions? Now let's just try to look at them together. The cholesterol level and yes, okay, longevity is inversely proportional. You say it's okay. Higher cholesterol level, lesser time left to live. Okay, so greater, lesser. Okay. Smoking and the likelihood of cardiovascular disease. Directly proportional. Okay. The more you smoke, well, okay, statistically, okay. Okay. The more likely is it that somebody will develop heart disease. Yeah, that's what you want to call it. Now, years of is okay. Years employed and days of vacation earned per year. Okay, you can say it directly. Okay. They may say, well, okay, as you start working and are employed properly, you can, okay, start talking about vacation. All right. So now the IQ and shoe size, they are not related. Clear? Now, guys, had they been directly related, then clowns would have been the most genius people. Okay. So that's okay. They are not related. You can have a foot size, whatever, and you may have as whatsoever IQ. So they are not related. Caloric intake and weight. Well, okay. You can say it directly. Okay. Okay, we can say it's okay. Hours spent exercising and weight. Inversely. Clear. Okay. Okay. That just skips number 7. I'm too drunk to talk about that one. Okay. The alcohol intake and it's okay. Sobriety is going to be inversely. Okay. But some people may use it's okay. Get drunk, you it's okay if hit by in the head by a beer bottle cap. Now, what is the reciprocal of 20? Traditionally, it's okay, 1 over 20 or 0.5. Okay. 0.5. Or in, okay, a scientific exponent written way, it's okay, it could be 1 multiplied by 10 raised to the power let's put it this way. 5 multiplied by 10 raised to the power minus 1. That would be 0.5. 5 multiplied by 10 raised to the power minus 1. Because that minus 1 will become 1/10. Okay, guys, question number 9. Okay. Now, which lines in the graph below represents as okay an inversely proportional relationship? And that's going to be as okay, what you can say as okay will be the black, the orange, and the red. Why? Because if you look at them, things will be as okay inversely proportional. Will start great and end less. So we can say, okay, here we says, okay, A and B. So they're going to be inversely proportional as okay if the graph between them is going to be going like this. Because we can say, okay, A started great and B started less. where we mainly says, okay, that as B increased, A decreased. Did that make sense? So any of those lines is okay, which went like this, or inversely proportional. Whereas, okay, we can say, okay, any line that goes like this, or let's say like this, or even like this, or even like this, will be directly proportional. Because we can say it like this way. This is A, this is B. We already know that this point here, so okay, was 0 for both of them. It's okay where you go up like this, the number increases. Likewise, okay, if you go like this, it increases. So as that's okay, A increases, B increases. So they both increase. So that will be as okay, directly proportional. Did you guys get that?
Yes.
Good. Whereas question number 11 is okay, just say which lines in the graph represent a relationship between the two variables. Here, not specifying is okay, we're talking about is okay being directly proportional or being is okay inversely proportional. But it's okay, which are having is okay a relationship. Which could mean that okay, it could either be directly proportional or it could have been inversely proportional. So that's going to be okay, all the 6 lines. Okay. Okay, in the directly proportional, inversely proportional, we had black, red, black, orange, and red. For the direct proportion, we had green, blue, and purple. Okay. But they were all related. So whether we says, okay, as one increase, the other will increase relatively or directly. Always says, okay, as one increases, the other will decrease. That's going to be as okay, inversely proportional. But whether inversely proportional or directly proportional, they are related. That's the only thing that we can find if something was related. And things which were not related, well, okay, yes, at least because it's okay, we will not be able to just okay draw a graph for that. Because there was no relation, or because it's okay, one factor does not affect the value of the other. Now, guys, before sending you guys on a lunch break, let me just ask one question. How many of you are, yes, okay, aware of what we call the metric system? Okay. How many of you know how to work with the metric system? Okay. Yeah, okay. I don't know why they haven't told you the metric system in the school, because the system that we use here now in the United States is universally obsolete. Even the people who has okay introduced it first doesn't use it anymore. even they switch on to metric system. So let me see if I be able to, yes, okay. Tell you, yes, okay, how the metric system works, which is relatively, yes, okay, very straightforward compared to, yes, okay, the household system that we use, okay, that is being used here in the United States. Okay, so I see you guys back at, should we say, 1 o'clock? After you guys have your happy meals. And let's see. Okay, guys, have fun till then. Now, before I start, does anybody have any question at this moment? Okay, guys. Now, let's try to see if we can get this thing here straight. So probably that's okay. The next topic that we were talking about, that is today. And US, US, okay, tomorrow to begin with, is going to be units. Okay, now let us put it this way. We can use any number. We can say 2, we can say 5, we can say 18, we can say it's okay, 201, whatever. What are these? They're all just numbers. Is that clear?
Yep.
Okay. Now, if I say 2, yeah, okay, 2 is 2, but 2 what? That what is going to be expressed by putting, okay, a specific unit of the 2. I may say 5, but 5 what? That what is going to just, okay, be clarified based on the unit. Likewise, I can say 18, I can say 201, I can say 16, I can say it's okay, 5,824. Any number. Okay, but without a unit, it will just be a number. Okay, where the unit main is going to just, okay, express or mainly as, okay, clarify as, okay, what is it again that we are talking about. Okay. Now, guys, and what I mean is, okay, just briefly as, okay, talk about today is going to be as, okay, the common units that we will be coming across in ultrasound physics. Okay. Now, guys, to start with, okay, there are going to be as, okay, some very basic units, which can be as, okay, unit of length. Now, we may say length, but okay, what is that going to mean? That's going to also be as, okay, expressed as the distance. Clear? Okay. Now, as, okay, the system that you, as, okay, that's been used here, as, okay, that's where they use, okay, as a unit of instance, for instance, okay, like an inch. You may use feet. You may use yards, and so on, so. You, as, okay, go extreme and say it's, okay, miles. Yeah, okay. Now, the unit in the metric system comparatively is okay. Okay. And now the basic unit in distance, yes, okay, is going to be, yes, okay, what we'll call a meter. Okay, so that is going to mean, yes, okay, be the basic unit that is going to, yes, okay, measure the length or distance. You can say, okay, the distance between this point and this point. And although, yes, okay, that is not going to be a meter. It's not even going to be a foot, for that matter of fact. But it's okay, by measuring this distance here, you could say it's okay, 7 inches, for instance. Clear? Okay. Okay. So 7 here means, as I said, that's okay, will just have been a number, but the inches mean that's okay, Charles. First of all, that's okay, what is it that this 7 here represent? It's going to represent something that is referring to as okay, the distance or length of something. And then it just tells us how many. Did you guys get that?
Yes.
Another basic common unit that we maybe talk about is going to be time. Clear? Okay. Okay. Now the one that we most likely as okay will use as a main basic is going to be seconds. Okay. But in some instances, okay, we may even use okay as the word as okay unit of time as minutes. And very rarely, not really, it's okay. We can even as okay go to hours. Okay. But we already as okay know that okay, yes. 1 minute was okay as 60 seconds. Okay, and 1 hour was 60 minutes. Okay, then you can go into day, then you can go into weeks, then you can go into months, then you can go into years, then you can go into decades, centuries, millenniums, etc., etc., etc. But what they basically are mainly as okay, all units that were expressing the amount of time. Okay. Now mainly as okay, guys, in ultrasound, mainly because it's okay, things happen very rapidly. Okay. Things happens very rapidly. That's why it's okay, we are going to talk about it's okay, smaller, smaller, smaller fractions of seconds and refers to those. But they are still going to be as okay representing time. Did you guys get that?
Yep.
Yes.
Okay. So anything that is okay accounts for that's okay time, how much time does it take? It's going to be expressed in either seconds, minutes, hours, days. Or we can say it's okay, milliseconds, microseconds, nanoseconds, so on, so on, so on. Now, another common unit that, okay, yes, we will be talking a lot about is going to be as okay, a unit of frequency. Now, we will talk further in details of, yes, okay, what a frequency and so on, so on, so is. Especially as okay, in context to, yes, okay, sound waves, which is the main, yes, okay, thing that we will be dealing with. But what a frequency mainly is going to be is okay, I guess it's okay, how many times there's an event occur in a period of time. Now you can take any event and any unit of time. We can say it's okay, for instance, okay, we take it's okay, a period of time as okay as 1 week. Right, okay. And then say it's okay. The event that we may talk about is okay. Does the sun rise? In a period of 1 week? That's going to be considered okay, the frequency of sunrise in a week. But that number is going to be 7 times in a week. Or we can even okay, say that it's going to is okay be once per day. Did that make sense?
Yeah.
Okay. So the number anytime is okay, and the numbers of time occurs whatever is okay. Unit of time that you are referring to is going to be referring to as okay, the frequency of that event. Clear? Okay. Now here it's okay, we just okay, so I used it as okay, something else, an event that could be counted in terms of days and so on. So actually, guys, that's okay when we talk about it's okay, sound waves. That unit of frequency is not going to be as okay per day or per week or per hour or so on. So, but actually, it's going to be as okay per seconds. Okay, so yes, okay, the number of times something occurs, or it's okay, certain an event occurs per second, that is going to be as okay, the frequency. Okay. And although it's okay, we may say it's okay, so and so and so per second. But the practical unit for frequency is going to be as okay, what we call hertz. Now you may have been seeing this term here as okay, referring to as okay, a truck rental company. Just like U-Haul. Okay? I think you can hire as okay, rent trucks from a company called Hertz. But this hertz here is okay, it's mainly going to be as okay, we can just say it's okay, number of sound waves per second. So that's going to be as okay, the frequency of that sound wave. So if a sound wave, for instance, okay, had 200 cycles completed in 1 second, that could be referred to as okay, as a frequency of 200 cycles per second. Or more correctly, a frequency of 200 hertz. Did that make sense?
Yep.
Yeah.
Use the word hertz. What would it mean? The number of cycles, especially okay, when we talk about sound wave, the number of cycles of a sound wave completed in 1 second. Clear? Okay. But we can also say as, okay, 200 cycles per second is a frequency of 200 hertz. Okay. We will talk more in detail about as, okay, frequency of sounds and hertz and blah, 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 beep, 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 okay, more related is, okay, to or specifically related to ultrasound in chapter 3. Okay. But mainly as, okay, anything that goes by waves can also be expressed as hertz, which is going to be, okay, how many waves are completed in 1 second? Did you guys get that? Okay. Okay. Now hertz, Hertz, as in zebra. That's how you spell it. But, dear guys, this hertz here can actually, okay, be symbolized by the letters Z. So this 200 hertz can also be just written as 200 Z. But the HZ mainly is, okay, just is a symbol for hertz. Did you guys get that?
Yep.
Okay, so that's okay. You guys, okay, should be able to guess that, okay, yes, this is something that we'll be talking a lot about. So whenever we talk about something, it's okay, it's going to be, it's okay, a form of frequency, because it mainly, it's okay, just accounts for how many times does an event occurs in a period of time that will be known as a frequency. Did you guys get that?
Yeah.
Now another unit is going to be, it's okay, what we call area. Now guys, just to simplify, it's okay, what the unit of area is going to be is, because it's okay, it's going to be the unit of distance squared. Now you can take any unit of distance. We can say it's okay, meter. And when you square that, that becomes an area. Okay, so no matter, it's okay, area is just going to, area is going to be expressed with a unit of distance or length being squared. If you don't want to square a meter, well, okay, yes, you can go to a centimeter. If you don't want to square a centimeter, well, okay, yes, or a meter, well, okay, yes, you can go to a kilometer. You don't want to square that, well, okay, yes, you can go to a millimeter. It doesn't really matter how big or small the unit is, or unit of distance is, but once you square it, it becomes an area. So there's no question about it. It's okay, unit of area is always going to be, it's okay, expressed by a distance squared. Now, if for instance, okay, aren't you buying a house? Or let's say it's okay, selling your house, you don't know. Either of those things would be a dumb thing right now. Okay. But one of the first things that you may as okay look up in an ad is okay, is what is the square area of the house that I'm looking for? Or you saw this nice ad on okay, yes, the internet and okay on a website and so on. So probably as okay, you saw okay, these pictures yes, okay, they look impressive. But is this enough square area for me? Or the area of this house here is okay, big for me. That's going to be expressed in square feet, square yards, square miles, whatsoever. Clear? So that would be as okay the area of the house. So it's always going to be as okay a unit of distance squared. That would be the area. You made it as okay width versus or width by length. That's going to be as okay the square area. Did you guys get that?
Yeah.
Good. Or we can say as okay, we have something like this. And let's say it's okay, it is 3 centimeters tall or wide. And let's say it's okay, 2 centimeters like this. So the area of this thing here is going to be as okay, 6 square centimeter. That's going to be as okay, the whole size of this box here. Now another unit, and okay, so since I mean yes, okay, bring it in here. It's going to be as okay a unit of what we call volume. Now some of you may remember yes, okay, when we talked about the volume of blood. Now, why was it that we use the unit volume here? Because okay, primarily because okay, blood was liquid. We can also say okay, the volume of a propane tank. Again, yes, okay, why do we use volume here? Mainly because this propane tank or yes, okay, was going to just okay, be able to yes, okay, store a certain volume of gas. So liquids and solids were yes, okay, expressed in volumes. Now, guys, the traditional unit of volume is a liter. Although, yes, okay, according to the system that you guys may use, it's going to be, yes, okay, you have units like pints, ounces, gallons, and things like that. Okay. Now, roughly speaking, yes, okay, we can say, okay, somebody wants to quantify, we can say 1 liter is approximately equal to 1/4 of a gallon. Or you can say it's okay, 4 liters equals 1 gallon. Just if somebody wants to, yes, okay, quantify these two things here. Did that make sense? Okay, so in the metric system, guys, okay, the basic unit for volume practically is a liter. Now, guys, usually it's okay when we talk about it's okay volume. You may hear people, yes, okay, use the unit cc. Have anybody ever heard the unit cc being used? No? Okay, somebody's nodding. No. Besides the person who is nodding, have any of the other people even the far or least idea of, okay, what cc stands for? The person who nodded, be quiet. No idea, you never heard of it, and you have no farthest idea of what it stands for.
I don't know what it stands for, but they like used it for like saline and stuff like that.
Okay, you get saline in syringes, right? Okay, which is going to be in cc's. Now, just to make sure, guys, okay, yes, this is not super mooper duper exactly the same, but it's so close to be the same that there's, okay, there's minute differences, okay, is, because it's, okay, neglectable. Okay, now, guys, all this, okay, this still, yes, okay, will be, yes, okay, a unit that is going to be used for volume. Or very main, you can say, yes, okay, that, okay, yes, this first C here actually, yes, okay, stands for cubic. And the second C stands for centimeter. Is that clear?
Yep.
Okay, centimeter, sorry. Now, guys, centimeter, that's practically as, okay, a unit of distance or length. To be more correctly, as, okay, that's going to be as, okay, 1/100 of a meter. And what the cubic here mainly meant is raised to the power 3. So area was when you, yes, okay, square the distance like this. Volume is going to be, yes, okay, if you use a unit of distance to measure it, that unit of distance has to be cubed. Okay, to represent volume. And what I said earlier, you guys don't mind if I go to another slide, right?
Nope.
Because now if you remember that, I say it's okay, x-axis plus y-axis plus z-axis. Or physically, it's okay, measure along these three axes here is okay using a unit of distance. The sum of these will become, oh no, that's okay, the product of these will become a volume. Otherwise, because I say it's okay, product of these two here is okay, would have been an area. Because the product of these two here is okay, would have been an area. The product of these two here is okay, would have been an area. But when we take all three, x, y, z, width, height, and depth, that becomes, and we measure those in terms of, yes, okay, unit of distance or length. That become a cubic volume, a value of distance, which will be a volume. Or just as we said, well, okay, yes. No, let's do this way. This comes this. Whatever they will measure is going to be the area. Now, if I just add, okay, as the third dimension, or we can say this one here, for instance, that all these is okay, no, or P is okay, a volume. Now, what is that I end up having? Is a cube, because I have widths, I have heights, and I have depths. Measuring distances along all three planes is going to be as okay, those distances in cubes. So what they mainly say is okay, that one cc, which was 1 cubic centimeter, which will mean 1 centimeter tall, 1 centimeter wide, and 1 centimeter deep. Will be 1 cubic centimeter. And it's actually that's okay equal to 1 milliliter. Yeah, this is going to be as okay 1,000 of the liter. So 1 cc is actually as okay the same as 1 milliliter. But with that said, your basic unit of volume will be liter. Or that can be multiplied or fractioned. Whereas, okay, if you want to express volume using a unit of distance, if you want to express volume using a unit of distance, then that distance needs to get cubed. Whereas if you only square the distance, it will become area. If it is neither squared nor cubed, but just plain distance is distance, which will be length. The distance from here to school is 15 miles. For some people, that may be the distance that you travel, right? Okay, to get to school. For some people, it's 115 miles. Okay, some people may just be living across the street, so that's okay. 20 yards. Or something like that, right? Okay? Okay, but when you square distances, it will represent area. When you cube it, it becomes volume. Did you guys get that? Okay. So that's okay. One mistake that many people makes when asked about it. Okay. So which is the unit of area? Yes, okay. It's going to be yes, okay. Any unit of distance squared. Okay. Any questions so far? Okay. So that's okay. Distance could be simple. Let's say, okay, the same centimeter, for instance. We can say it's okay. Area. Yes, okay. Using the unit of centimeter is going to be centimeter square. Whereas, okay, if we say that's okay, volume using a unit of distance is going to be yes, okay, centimeters cube. Okay, now what a centimeter is, well, okay, it is going to be yes, okay, fraction of a meter. How big or smaller fraction? Okay, we'll probably get to that thing tomorrow. Now, guys, another unit that we will come across. Or something that's going to, it's okay, be expressed by a unit is going to be speed. Now, mainly as okay, just to this okay, it's okay, simplify as okay, speed is going to be as okay, how fast, or let's say it's okay, slow, is it an object is moving. Yeah, okay. Although we can also say as okay, or more scientifically as okay, say it is going to be the distance an object moves in a unit of time. So mainly that's okay. Again, that's okay because speed here is going to be as okay dependent upon two things. Or we can say it's okay related to two things. That's why it's okay. The unit of speed is going to be made up of two factors. One, a distance per time. So the unit of speed can be any unit of distance or any unit of time. Now, the next time you sit in your car, yes, okay. On your dashboard, there's something that is called a speedometer. If you guys know what that is. You may not have been bothered looking at that thing. Okay, I can see, yes, okay, some speeding violators who are smiling. No, okay. But what did that tell you? That tells you, yes, okay, how fast or slow is it that you're going? How is that expressed? Mainly, yes, okay, by a certain distance that you'll be able to cover in 1 hour if you carry on by the speed that you're going at. Did that make sense? So yes, okay, what would be the distance? Okay, again, yes, okay. Most cars, yes, okay, go by miles nowadays. So yes, okay, here. But you may see two numbers, yes, okay, miles per hour or kilometers per hour. So the miles or kilometers, I mean, yes, okay, just two different units of distance. An hour is going to be, yes, okay, a standard unit of time, right? Now, yes, okay, if you guys are law-abiding motorists, let's say that, okay, yes, you may be going by the speed of 60 miles per hour. Did that make sense? Which mainly would mean that, okay, as once one hour has been, okay, completed on your watch, you had moved to a point which is 60 miles away from, okay, where you started. Did that make any sense?
Yeah.
Good. Now, guys, usually it's okay when we talk about speed. There mainly is, okay, there's going to be two main speeds that we're talking about in this book here. One is going to be, okay, what we'll call the speed of sound. The details of that thing will be in chapter 3. And then it's okay for a long period of time. We may not directly talk about speed of sound. We may just refer to it as okay, or we already know about it. But then it's okay in a later chapter, which is going to be okay, chapter 19. We maybe start talking about okay, speed of blood. But actually, it's okay, change from the word speed and talk about what we call velocity. Now, as far as the unit of speed and velocity is concerned, it's going to be the same, a unit of distance per unit of time. Okay. So what is the difference between, okay, speed and velocity if it's the same unit? The thing that velocity gives you which speed doesn't is direction. So you can say, well, okay, I was driving my car or bike or whatsoever at 100 miles per hour. Well, okay, yes, that's 100 miles per hour. That's the speed. It doesn't tell me whether you are driving or it's okay, riding northbound, southbound, eastbound, westbound. Or what direction. Traveling towards New York, Massachusetts, New Jersey, Florida, whatever. But if you go like this and say, well, okay, I'm traveling east at 100 miles per hour. Okay, now I know that's the direction in which you are heading. So just by giving us, okay, that direction, yes, okay, you actually gave me the velocity. So velocity is nothing more but speed and a relative direction. Did you guys get that? Okay. But that'll be as okay, chapter 19. But that speed is still going to be as okay expressed as a unit of distance per unit of time. Did that make any sense at all? So yes, okay, guys, next time you yes, okay, start your cars or bikes or whatever. Yes, okay, press the gas and hit the road. That's okay. Try to yes, okay, also yes, okay. Not get concentrated on that thing, but yes, okay. From time to time, yes, okay, just look at it and say, okay, how fast or slow is it that I'm going? And sometimes you may be surprised. You say, oh, I didn't know I was going that fast. Okay, or you may say, okay, why are the people behind me honking at me? Well, okay, yes, if you're going 20 miles an hour on a highway, of course they're going to be honking at you. Okay. But that was your speed. Any questions, guys? So that's okay. The distance covered in a unit of time is your speed. Now, guys, have any of you heard of this fellow here?
Yep.
Yes. What does that mean?
It's the weight of something.
Huh?
It's the weight of something or
Okay,
an
so
object.
okay, no. Okay, good. Because usually that's okay. Many people, that's okay, may confuse this here by weight. Now, in terms of physics, it's okay. We know that weight is just okay due to pull off gravity. Or at least that's what we believe now. Let me put it that way. Clear, okay. Whereas mass, although it's okay being measured, or it's okay being measured or presented in what we call, it's okay, called the unit of weight, is actually something wrong. Okay. So, but mass, that is mean it's okay, going to be it's okay, mainly used as okay represent how much of a solid mass, solid material. Clear. Did that make sense?
Yeah.
And then it's okay when you put it on a scale, it tells us, well, okay, yes. 2,000 kilograms or something like that. So that's mass. So that's pretty much okay. That's what most people, yes, okay, may confuse with weight. Okay, yes, okay, you guys may go by pounds, ounces, and so on, so as well. Or yes, okay, checking what lay people will call weight, but which actually is okay, the mass. Now, although yes, okay, in what we call the metric system, although yes, okay, in the metric system, yes, okay, the actual, yes, okay, basic unit for mass is what they call, yes, okay, a kilogram, which actually, yes, okay, will mean 1,000 grams. But that's what they consider to be as okay, the basic unit of mass in the metric system. You guys know why they call it the metric system? Well, you will realize that okay, it's going to be a system of tens when we start talking of its conversions. Okay. Now the official name of what you guys here may refer to as the metric system is MKS. MKS. Where M stood for meter, which is the standard distance or unit of distance. K for kilogram. Or what they mean is, okay, we just call it, okay, a kilo. And S, second. Okay. So time, no, sorry, yes, okay, time, length, and mass. Now the system that you guys use here is okay, where you use things at a second, it's still going to be a second. But then you have yards, and then you have pounds, right? Now, who introduced that system and who introduced the metric system? Any clue? No clue. Okay, why do you think that as they didn't want to adopt the metric system in the United States to begin with?
Well, didn't it start over in England?
The metric system?
Like the UK?
No. You go to UK, they are they're probably sliding away from it now. But they were the ones who introduced things like pounds, yards, and so on. So the metric system was mainly introduced primarily by the French. So a little weird, you want a Statue of Liberty from the French, but you don't want to deal with the system in which they measured it. Just build it for you. But declaring independence from Britain. Okay, but you say, we're keeping the pound, we're keeping the yards, we're keeping the seconds. Ah. Okay, but that's just okay. Okay. So that's okay. That's standard 1 meter measuring stick, if that's what you want to call it. That's okay. This distance here is from now on going to be considered a meter. I believe it's okay, is in a museum in France. And so it's okay, the first stone of a kilogram or a kilo is in France. So they were okay. Okay, guys. So these were just okay as some of the units of some parameters. Okay, now tomorrow is okay, talk about some other units. And then we can go into yes, okay, fractions and multiples of these units here and how they are documented. And then okay, yes, the difficult part, which is not really that difficult. You just have to learn the cheats. Is how do we convert from one unit to another unit, or from a bigger unit to a smaller unit, or vice versa. Okay, so yes, okay. Tomorrow, yes, okay. We will have to yes, okay, waking up that inner mathematician in you. Okay. Okay, guys. Hope you like the first class. Okay. So, yeah. You can see the chapter says, okay, just the basics. So that's okay. It's not really ultrasound. It's not really ultrasound physics. It's just basics, math, or that's okay, whatever you want to call it. That's okay, study of relationology. Okay. That way, it's okay, carry on with us. Okay, guys. Now, stay warm, stay blessed, and take care of yourselves. And have fun.
See you tomorrow.
Okay, see you
Bye.
tomorrow.
See you tomorrow.
Thank you.
Bye-bye. No problem.